Hey, what is up guys, and I'm here to talk about the top 5 rarest elements on the earth. Number 5. Neodymium. Neodymium is the chemical element with the symbol Nd and the atomic number of 60. It is a soft silvery metal. It was discovered in 1885 by the Austrian chemist Karl Ore von Welschbach. It is present in significant quantities in the ore minerals monazite and bastnasite. It is not found naturally in metallic form or unmixed with other lanthanides, and it is usually refined to be used. Another important use of neodymium is used to make high-strength neodymium magnets, a very powerful permanent magnets. These magnets are widely used in such products as microphones, professional loudspeakers, in-ear headphones, high-performance hobby DC electric motors, and computer hard disks, where strong magnetic fields are required. Larger neodymium magnets are used in high power versus weight electric motors and generators for wind turbine. Number 4. Promethium. Promethium is the chemical element with the symbol Pm and the atomic number of 61. All of its isotopes are radioactive. It is one of only 2 such elements that are followed in the periodic table by elements with stable forms. It is a lanthanide which forms salts when combined with other elements. There are 2 possible sources for natural promethium. First is rare decays of natural europium-151, and the second is uranium. Practical applications exist only for chemical compounds of promethium-147, which are used in luminous paint, atomic batteries, and thickness measurement devices, even though promethium-145 is the most stable promethium isotope. Because natural promethium is exceedingly scarce, it is typically synthesized by bombarding uranium-235 with neutrons to produce promethium-147 as a fission product. Number 3. Californium. Californium is a radioactive chemical element with the symbol Cf and the atomic number of 98. The element was first synthesized in 1950 at the Lawrence Berkeley National Laboratory by bombarding curium with alpha particles. It is an actinide element, the 6th transuranium element to be synthesized, and has the second highest atomic mass of all the elements that have been produced in amounts large enough to see with the naked eye. The element was named after the university and the state of California. It is one of the few transuranium elements that have a practical applications. Most of these applications exploit the property of certain isotopes of californium to emit neutrons. For example, californium can be used to help start up nuclear reactors, and it is employed as a source of neutrons when studying materials using neutron diffraction and neutron spectroscopy. And it can also be used in nuclear synthesis of higher mass elements like element 118. Element 118 was synthesized by bombarding californium-249 atoms with calcium-48 atoms. Users of californium must take into account radiological concerns and the element's ability to disrupt the formation of red blood cells by bioaccumulating in the skeletal tissue. Number 2. Francium. Francium is the chemical element with the symbol Fr and the atomic number of 87. It is the least electronegative element, and it is the second rarest naturally occurring element. It is a highly radioactive metal that decays into astatine, radium, and radon. As an alkali metal, it has 1 valence electron. It was first discovered by Marguerite Bray in France, from which the element takes its name in 1939. It was the last element first discovered in nature. Outside the laboratory, francium is extremely rare, with trace amounts found in uranium and thorium ores, where the isotope francium-223 continually forms and decays. As little as 20 to 30 grams, or 1 ounce, exists at any given time throughout the Earth's crust. The largest amount produced in the laboratory was a cluster of more than 300,000 atoms. And here is for the grand finale! Number 1. The rarest element on the Earth is astatine. Astatine was named after the Greek word unstable astatos. It is a naturally occurring semi-metal that results from the decay of uranium and thorium. In its most stable form, astatine-210, its half-life is just 8.1 hours. Meaning, if you have it, it will just be gone at the end of the workday. It it will either turn into isotopes of bismuth 206 or polonium 210. This instability combined with its actual scarceness means that at any given point, there's less than 30 grams of it in the Earth's crust. If scientists need to use it, they would have produced it from scratch. That being said, only 0.05 micrograms of astatine have been produced to date. No one has ever seen it in its elemental state, so scientists assume it would take on a dark or metallic appearance if you could see it. I hope you liked my video, so please like, share, and subscribe. Have a nice day, guys!